Okay, this is the second video covering chapter 6, confidence intervals. Find the margin of error for the given value of C, sigma, and n. There is a formula for the margin of error. The formula says E equals ZC times sigma divided by square root of n. But we don't know Z. We have the confidence interval 90%. Actually, if you open here, it's going to give you the confidence. 90% ZC is 1.645. So we have it here. So your margin of error will be 1.645 times, let me type it here, times sigma, which is 3.9, and then divide by square root of n. Square root of 36 is 6, so divide by 6. And this is your margin of error. You put it in there. Use the confidence interval to find the margin of error. If you are given the confidence interval, you want to go backward and to find the margin of error, here's how you do it. You subtract the lower value from the upper value. So it will be 0.55 minus 0.454 and then divide the answer by 2. That will be your margin of error. To find the sample mean x bar is always in the middle of any interval, so you just add them up. 0.454 plus 0.55, add them first and then divide, order of operations, then divide by 2, so that's your answer. Find the minimum sample size needed to estimate the mean for the given value of C, sigma, and E. There is a formula for n. The formula for n says n equals ZC times sigma divided by E quantity squared. Now, what is ZC at 98%? I did show you how to find the critical value if you have the confidence level. Here's how you do it. You take the 100% and subtract it from 98%, so you get what? 2%. Divide the 2% by 2, you get 1%. And then you go to inverse norm. The 2% divided by 2 will be 1%, which is 0.01, comma 0, comma 1, paste. And it is, if you round it to 2 decimal places, it's 2.33. So now, to find the minimum sample size, you take the 2.33. However, if the confidence level was 90% in the previous exercise, I showed you how to find Z. It was 1.645. Just click on the table and get the value. Times sigma. What is sigma here? 7.3. And then divide by E, which is 1. So I'm going to just divide by E. And now you have to square this. That's a formula. So now square. Okay. When you enter your answer, the sample size, it has to be a whole number. So you round up. And look, he says round up here. So when you enter the answer, you have to put 290. That will be your answer. Okay. I'm going to go to the next question. You are given the sample mean and the population standard deviation. Once he gives you the population standard deviation, guys, don't think of T interval. It has to be Z. Use the information to construct a 90 and 95% confidence interval. So let me just go to second, stat. Sorry, it's a stat, not second. And then tests. And now Z interval. Again, if you ask me why I'm going to Z intervals, because he says the population standard deviation is given. And look here, it's asking you for sigma. So what is sigma in this problem? It's assume the population standard deviation 10.01. X bar is what? 114.34. N is what? What was N? 38. What's the confidence level? He wants 90 and 95. So we'll do 90 first. And that's your interval, 111.67, 117.01. You write it down right here. You put the lower bound here, 111.67, and then you put the upper bound. The 95% confidence interval, you go to stat tests, Z interval again. You don't change sigma, you don't change that, nothing. It just change the confidence level. It's going to be a wider interval. Always when the confidence level is bigger, larger, you get a wider interval. And here you go, 111.16. You put it right here, and then 117.52. Which interval is wider? Definitely the 95% interval. Now, how do you make a conclusion? You say, you can be 90% or 90% confident that the true mean is between this value and that value. So you look it up here and you select that one. I think the population, you can be 90% confident that the population mean price of the stock is between the bounds of the 90% interval. Yeah, that would be the one. Okay, want to leave the question. A publisher wants to estimate the mean length of time in minutes on all adults spent reading newspapers. To determine this estimate, the publisher takes a random sample of 15 people and obtains the results below. From past studies, the publisher assumed that sigma is 2.1, so we know what sigma is, guys. So it's still a z minutes, and the population of times is normally distributed. Construct a 90 and 90% confidence interval. First of all, you have to enter your data in L1. Let me just clear this, and I'm gonna pause the recording now until I enter this. Okay, so go to stat, tests, z interval. Again, usually when you have a raw data set, it's a t interval, but here he gave me sigma, so I have no choice but to go to z. Okay, what is sigma? 2.1. Oh, sorry, I have to go up. I don't have summary, I have data, so select data. And now my data is in L1. Don't touch the frequency. What does he want? 90 and 99%. And here's the interval, 8.57, 10.36. You put it here. Now a 99% confidence interval, so you go to stat, tests, z interval. The only thing is just change this to 99. Which interval is wider? Definitely the 99%. Find the critical value TC for the confidence level C equals 0.95 and the sample size N equals 12. If you click on the table, guys, you look for the confidence level 95 and you look for the degrees of freedom 11, which is 12 minus 1. Degrees of freedom of sample size minus 1, and you get it. So 95 will be this, 2.201, and that's it. Let me close this. Construct the indicated confidence interval for the population mu using t distribution. I will be shocked, guys, if you go and do a z distribution here, because he says t, so it must be a t interval here. Assume that population is normally distributed. He's not giving you a population standard deviation. He says the population is bell-shaped, which is the true assumption always. So we go to stat, t interval. You can see number 8. I don't have a data here, so I'll move back to summary. X bar is what? 13.8. S is 4. And N is 5. And calculate. And I got the interval. He says round to 1 decimal place, so it will be 5.6 when you enter it here. And 5.6 and 22.0. And that would be your interval. Next question. In a random sample of 12 people, the mean driving distance to work was 23.9 miles and the standard deviation was 6.7. He didn't say this is population standard deviation, so this is S. You're done with Z. It's T now. Assume that the population is normally distributed and use the t distribution. See, he's given you the hint to find the margin of error and construct a 90% confidence interval for the population mean. If you want, guys, hold on into the margin of error until you find the interval, and I'll show you an easy way to find the margin of error here. So go to stat, tests, t interval, stats. Okay, what's x bar here? The mean driving distance was 23.9, that's x bar. S was 6.7. N is what? How many? And there are 12 people. You can read it. Confidence level is 90%. Okay, so you got the interval here. 20, how many decimals? One per place. So 20.4 and 27.4. Now the question is up here. What is the margin of error? If you have the interval, guys, you can subtract the lower bound from the upper bound and divide by 2. So 27.4 minus 20.4 will be 7. Divided by 2 will be 3.5. And the unit of the margin of error is the same as the unit of the variable. And what's the unit here? In miles. So it will be in miles. Okay. Interpret the results. With 90%, what did we do? 90%? Yeah. With 90% confidence, we can say that the true mean is between 20.4 and 27.4. So we look for the language that says this. It can be said that, no, with 90% confidence, it can be said that the population mean driving distance to work is between the intervals and the points. The intervals and the points, guys, means those two values, but they don't list them because this is a general conclusion here. So that will be this, but you have to put 90% confidence. Next. The state test scores for 12 randomly selected high school seniors are shown on the right. Complete parts A through C. So let me pause here and put... okay, I have the data in L2. He wants X bar and S. Let's do the interval first, guys, and then you'll get everything. You're going to get the mean, the sample mean in S and the output. So it's T interval. He didn't give me sigma. If he doesn't give you any, he doesn't mention population standard deviation, guys, you can blindly think of T distribution. So stat T interval. Okay, I don't have summary here. He gave me the data, so you have to switch to data. Where did I put my data? In L2. How do you choose L2 here? You just put the second key and then number 2. Enter. Frequency, leave it as 1. What does he want? 90% confidence, and hit calculate. And look, guys, you get the answers of all 3 questions in one screen. The interval is 752.48 and 1067. Your X bar, you just put it here, 909.75. What does he want? 1 decimal, 909.8. And S is 303.4. Don't be surprised, guys, if you do this exercise on your own online and get different answers, because the data is going to change. You're going to get probably different data set. So don't assume they're going to be the exact same exercises. And then you put the interval here, which is what? 752.5, 1 decimal place, and then 1067. That's it. The gas mileage in miles per gallons of 27 randomly selected sports cars are listed in the accompanying table. Oh. So you guys, you either can open this in StatCrunch and do it, or you can put this into the calculator and do the same thing that I did with this exercise and run a T interval. Let me see if I can show you how to do this in StatCrunch. Open in StatCrunch. And watch, guys, you can go to stat. It's T, not Z, because he didn't give me population standard deviation. 1 sample with summary. Not with summary, it's with data. He gave me the data, sorry. Okay, that's the variable. That's the confidence level. And whatever confidence level he gave you, I don't remember what he says. Let's say he says 95%. Hit compute. Okay, look guys. This is the interval. The lower limit and the upper limit is the interval. This is the sample mean, 23.925. You can also do this using your calculator. You will input the data into your calculator just like in the previous question. So, and run t interval. You will get the interval, you will get x bar, and you will get s. Okay? But let me just check one thing here. Assume that the mileage are not... the mileages are not normally distributed. So the original population is not normally distributed. How many items do I have here? If I have less than 30, I would not be able to proceed with this problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, it's less than 30. So actually there is nothing you can do in this problem. You will not be able to answer it. So that will be this. I'm sorry. I just was assuming that the population is normal. But he says, look here. This is the first question that we come up with. And he says, assume the mileage is not normally distributed. If the original population doesn't look like bell-shaped, you must have a sample size of more than 30. But here our sample size is 27, so there is nothing we can do. Just you don't do this question. The next question, he gives me the population standard deviation. He gives me 25. And he assumes that the population is normally distributed. So we can go ahead here. You put your data in L1, or you can do it in StatCrunch. Let me just show you how to do this in StatCrunch. Which distribution should be used to construct the confidence interval? It's a Z distribution. Why? Because look, he says the population standard deviation is 1.37. Z distribution means the normal distribution. Yeah, use a normal distribution because sigma is known and the data are normally distributed. Then he wants the 90% confidence interval. Let me show you how to do it in StatCrunch. You go, here is the data set. You go to stat and you go to Z-stat because it's a normal one sample with data. This is the data. What was the standard deviation given in the problem? Let me look it up. It was 1.37. So let's see if we can bring StatCrunch back. 1.37, you put it here. And he wants a 90% confidence interval. Compute. There's a lower limit, guys, and that's the upper limit of the interval, and that's x bar sample mean. Okay. Next. In a survey of 2,102 adults, 1,436 say that they have made a New Year's resolution. He's going to ask you to find intervals of the proportion. You don't have different ways here, not a Z interval, T interval. It's a proportion Z interval. So let me show you how to do this. That's it. It's letter A, enter. Okay. X is the smaller number, so it's 1436. And N is the larger number, 2102. And what does he want? 90 and 95. So this is the first interval, 0.664 and 0.699. You put it here. He says round to 3 decimal places. The 95% confidence interval, guys, you just go and change the 90 to 95. And here's the interval. Okay. And to make the statement, it can be said with 90% confidence that the true proportion, not the sample proportion, never, it's a population proportion, is between the endpoints of the interval. Always. Population mean population proportion from here between the endpoints. This is called an endpoint, this one and that one. Which one is wider? Always the 95% is wider than the 90%, so you don't even need to look at the values. In a survey of 2,957 adults, 1413 said that they have started paying bills. That should be an easy question, guys. If I ask you to find a confidence interval of the proportion, here's how you do it. Same thing as I did the one before. And I got 1413 for X and 2957, and confidence level is 99. There you go, that's the interval. Interpret the results. Not this one. This is about sample proportion. The sample proportion we already know. The sample proportion is X over N. We know it. We don't need to do analysis on this one or do prediction. So it is the population proportion. So your answer is this. A researcher wishes to estimate with 99% confidence the population proportion of adults who support labeling legislation for genetically modified organisms. Her estimate must be accurate within 4% of the true proportion. Okay. So within, anything that comes after within, guys, is the margin of error. So E is 4%, which is 0.04. The formula... Okay, no preliminary estimate is available. Find the minimum sample size. The formula N, guys, is P hat times Q hat times ZC divided by E quantity squared. Since he didn't give me a preliminary estimate, so P hat and Q hat will use 0.5. So there will be 0.5. Let me just do it here. 0.5. I'll go to this side here. Times 0.5 times open parentheses. Okay, we need ZC. 99%. What 99% is 2.575. You should try to memorize those values. Divided by E, which is 0.05. That's the margin of error. Close it and square it. You will see the formula, guys, on the test. You don't have to memorize it. And now you have to round up. Always it's rounding up. So your N will be here 664 when you round up. What would be the minimum sample size needed? Using a prior study that found that 69% of the respondents support labeling legislation. So now we already know P hat 69%. So that will be 0.69. I'll write it down here. Times, what's a Q hat? Subtract 0.69 from 1 or from 100%, it will be 0.31. Times, okay, ZC doesn't change, 2.575 divided by 0.05 quantity squared. There you go. So it has to be smaller. 567.3, which is 568. How do the results A and B compare? Having an estimate of the population proportion raises the minimum sample size? No, it doesn't raise it. It lowers it, actually. So, reduces the sample size. And I will stop here, and then there will be a third video covering chapter 7.